Okay, the next basic idea was that you have two lines and you try to determine where they meet without graphing them. You do not want to make the graph. The graph is very impractical to have to draw where the two lines meet. So if two lines are going to meet, they're only going to meet in one place. So what we're going to do is we're going to solve for where they meet algebraically. So we're going to use equations and we're going to use elimination to do this. Okay, so here are the two equations. The top one is a line, and the bottom one is a line. These are two different lines. If you were to draw these lines, which is ridiculous, they would meet in one place, and you'd be able to read off the graph where they met. I don't want to do that. I want to do this using algebra. So what I'm going to do is add them together, straight up and down. You add them vertically. When you add them up, the goal is to eliminate one of the letters. Now, obviously, I rigged this first example to work out ridiculously easy. 3x and 2x. 3x plus 2x. Is it 5x squared? 3 apples and 2 apples is 5 apples, not 5 apples squared. So don't make a ridiculous mistake here. If you had 2 y's and I took away 2 y's, they leave you with nothing. If I do equal sign plus equal sign, I get bigger equal sign. 6 take away 1. Remember, you're adding. Negative 1 plus 6 is 5. And then you solve this. Boom. Done. Yay! All done. The problem is you're not all done. The problem is that you're looking for the point where these two lines meet, and you only found half of it. So you have to take this number and plug it back into one of the equations. And the question is, which one do you plug it into? This point is where the lines meet. So it is on this line, and it's on this line. So it doesn't matter which one you plug it into. I'm going to plug it into the top one, and I'm going to figure out what the y value is. Okay, so in the first step, I eliminated y by adding the equations together, and I got x equal 1. Now, I'm going to figure out the value of y. I'm going to replace x with 1. Wherever you see x, you put 1. And then I'm going to solve it. 3 times 1 is 3. Subtract 3. I'm going to write every step. Those cross out. Right? Basic linear equation. Letter on the left, number on the right. Negative 1 take away 3. You make a sign mistake here, you're going to get your answer wrong. Be very careful. If you lose 1 and you lose 3, more, you lost 4. Divide by 2. That's it. This is the point where the lines meet. And I figured it out without actually drawing the lines. However, I'd like to check that this works. I want to make sure that this point is actually on both lines and it's where they meet. So I'm going to use, this was the original equation, the top one. This was the bottom one. I'm going to use this one to check my answer to make sure that the point that I got actually works. So I'm going to put x was 1, y was negative 2. 2 times 1 is 2. Minus 2 times minus 2 is positive 4. Well, son of a gun. Yay, it worked. Boom. So I eliminated y. I solved for x. I took the x, I plugged it in, I solved for y. Then I made sure that it worked by plugging it into the other equation that I didn't use. This is what you're going to do. Okay? Okay, so before I talk about the overall strategy, I wrote up another example. Now notice, if I try to add these right now, 2x and 6x makes 8x. Doesn't eliminate. If I add 3y and 5y, I get 8y. Again, doesn't eliminate. I have to add these together so that one of the letters eliminates. One of the letters has to be gone. So I'm going to have to alter one of these. I'm going to have to alter it in a way that the numbers in the front of that letter are the same with a different sign. For in other words, if I had a -6 here, I'd be able to add them up. -6 plus 6, they would cross out. Here, though, there's no way that I could make 3 into a 5. These are not multiples. You can't easily... I could turn 3 and 5 into 15, but that would require me to times this by 5, and I'd have to times this by -3 to make a 15 and a -15, and that is way too much work. If I want, all I have to do here is multiply this one by a -3, which will create the same number in front with a different sign. That's the goal. So before I work this problem, I'm going to write the steps. But the goal is always, I want this to be a -6. So I'd have to times this entire equation by -3. Every single thing would have to get multiplied by -3, and it would create a new equation. I'm going to do it again in a minute after I write the steps down. But this would be the goal. If I add them now, the x's cross out, and I can solve for y and figure out what y is. Once I know y, I can plug it back in and get x. So this is what you're going to do. So I'm going to write an outline of the steps that you would follow, then I'm going to continue to work that example from the beginning. Okay, so here's an outline of the steps you're going to follow. First, you got to pick a letter to eliminate. This step is not trivial. You need to look and think for a minute. For example, when I write the problem that I had up a minute ago, you'll see the y had a 3 and a 5 in front of it. So this is not a good choice for you to eliminate because you have to do too much work. Now the x's had a 2 and a 6. You can easily turn a 2 into a -6 by multiplying by -3. So, you have to make a decision here about what letter you're going to go after. So I put that step there separate because it's not a trivial step. You got to think about what letter makes sense to eliminate. Once you've done that, you want to figure out what you want to turn the number into. In order to do that, you have to multiply one, and it's possible you might have to multiply both equations so that the number in front of the letter you're trying to eliminate is the same but with opposite sign. Now I wrote in red to stress the importance of this. If you had a 6 in front of the x, you need a -6 in front of the other x. If you had an 8 in front of a y, then you would need a -8 in front of the other y. The numbers must be the same, but they have to have a different sign because you're adding them together to eliminate. Once you've created the new equation, so step 2 is making a new equation. It's taking one of the equations and altering it. You are multiplying it by something like 2 or 3 or -3. You're multiplying it to make a new equation. You take the one you just built. You just made a new equation. You take that one and you add it to the other one that you had in the original problem. Once you do that, the letter, if you did step 2 correct, one of the letters will disappear. And you'll have a letter left over. If you eliminate x, you'll have y left over. If you eliminate y, you'll have x left over. But whatever. So this is the key step though. Once you add them together and the letter drops off, you solve for the remaining letter. Then, once you know that one, if I know x, I can plug it back in and get y. If I found y, I could plug it back in and get x. Either way, this is it. And you should, in the example I worked in the beginning, I took the answer I got and I made sure that it worked. You have no excuse here. It takes literally 30 seconds to plug the numbers back in into the other equation and solve. Remember, in step 4, it doesn't matter which of the original equations you use. There's going to be a top one and a bottom one. If you want to use the top one to solve for the missing letter, fine. Use the bottom one to check. If you want to use the bottom one to solve for the missing letter, then use the top one to check. You always have 2 equations, okay? So these are the steps that you're going to follow every single time. You will always do these steps in this order, okay? Now I'm going to go back and I'm going to work the example that I had. I'm going to put it up again and I'm going to work it all the way through. Okay, so the example that I had up before is there again. I'm going to go through it just like I hadn't done it before. I'm going to make my quick analysis. I can definitely turn a 2 into a 6. I cannot turn a 3 into a 5, and I can't turn a 5 into a 3, okay? Unless you want to get nuts and multiply this by a fraction. So, yeah, I could turn 3 into 15, and I could turn 5 into negative 15 and add them together and eliminate. That's a lot of work. I don't want to do a lot of work. I always tell you guys, take the path of least resistance, all right? You want to do as little as you can. If you can do a problem in less steps, then you do it in less steps. I can very easily turn this 2 into a negative 6. I don't want to turn this into 6. 6 is not going to help me. I'm not subtracting these equations. I am adding them together. So I need this to be a negative. So I'm going to multiply this entire top equation by negative 3. You have to make sure every single one of these gets multiplied. And for convenience, I'm just going to write it right underneath that one. So let me make my arrow. So I'm going to do negative 3 times 2. That gives me negative 6x. Negative 3 times positive 3y is negative 9y. And then negative 3 times 7 is negative 21. You have to be very careful with the signs here. Okay, so my step 1 was just a little analysis on the side. I should go after x. This is basically my step 2. I multiplied the top equation by negative 3. I changed it. I made a new equation so that I can add them together. Put the little plus here so you understand you're adding. 6x, take away 6x. Nothing. Gone. Negative 9y plus 5. Negative 9 plus 5 is negative 4y. Now again, be careful with your signs here. You're doing negative 21 plus 9, which is, I would usually pause and wait for a response from the class, negative 12. Divide by negative 4. Again, watch your signs. Remember, 2 wrongs make a right. A negative over a negative is a positive. So you get a positive 3 there. Yay! Okay, remember, you were only half done at this point. I altered the top equation so that I could add them together and eliminate x. I eliminate x. Now I solve for y. You are never going to eliminate the same letter over and over and over again. Sometimes you eliminate x, sometimes you eliminate y. It depends on the numbers that are in front. Sometimes it's easier to eliminate x. Eliminating y would have been a lot of work. Now, I have to take this number and plug it back into either of the original ones. This time, I'm going to plug it into the bottom one and get the value of x. And then I'm going to check it using the top one. So I'm going to do a little erasing and then I'll do that step. All right, so I already eliminated x and solved for y. Now I want to figure out what x is. So I'm going to replace the y with the number that I got, which is 3. And I'm just going to compute it. 5 times 3, remember this is multiplication, 15. Now I'm going to subtract 15 from both sides. Remember, letter on the left, number on the right. That's the game that you have to play. Negative 15 plus 9. If you owe me $15 but you pay me 9, you still owe me 6. Divide by 6. Negative 1. That's your point. This is the point where the lines meet. I mean, you have to always remember and understand what it is you're doing. I'm looking for the point of intersection of 2 lines, and I'm doing it without graphing them. I don't want to graph the lines. I have no interest in graphing the lines. It's a lot of work. I want to figure out where they meet algebraically. Now, I said that I was going to check whether this point worked using the top original equation. So notice, I used the bottom equation to solve for x. Now I'm going to use the top equation to check. Okay, so like magic, the bottom equation is there now. I'm going to replace x with negative 1, because that's what I got. I'm going to replace y with 3, because that's what I got. I think you can already see that this is going to work. 2 times negative 1 is negative 2. 3 times 3 is 9. And I'm pretty sure that 9 take away 2 is 7. So I know that it works. You have no reason not to check this. I mean, how long did this take me? 10 seconds? Check that the answer you got works. Use one of the original equations to solve for the other letter. Use the second original equation to check that the answer you got works and makes sense. Okay, so this is the idea. This is called 2x2 systems of equations by elimination. I probably should have wrote the title in the beginning, but I didn't. So, oh well. And we don't care about that anyway. All right, so this is the process. If you want to watch the examples again, go back and watch from the beginning. Watch the original example that I worked. The original example was easy. The numbers in front of the y they were already the same with different signs. So all you had to do was add them together. This example I had to work though. Now, all right, just as a brief little summary. I wrote 2 more equations. These are BS equations. You can't solve them. I put smiley face, sad face, and question marks. If I were doing this top question, I would look and say to myself, there is no way that I'm going to eliminate y. Look at the numbers in front. You have a 9 and a -7. I'd have to turn these both into 63. I'm not doing that. This is crazy. This is too much work. If I was doing this question, I would eliminate the bottom one. I'd eliminate the x. I'd multiply the bottom one by -2 and get a -4x there. And I'd eliminate x and solve for y. Now, if I was doing this one, same thing here. I'd have to make this into a positive 33 and this into a negative 33. Screw that, I'm not doing that. All I have to do is multiply this top one by 5, positive 5. That turns this into 10y, and you have a negative 10y, and you can eliminate y. So one example, you'd eliminate x. Another example, you'd eliminate y. Here I had to multiply by a negative. Here I had to multiply by a positive. You have to look at the numbers and make a choice of what letter is easier to eliminate. If you see a multiple, 4 is a multiple of 2, 10 is a multiple of 2. So that's the letter that you want to go after. So, and then you decide what you multiply by and you do it, okay? So hopefully this helped. I'm going to upload the worksheet for you guys to work on, and we'll meet in our virtual class and go over any that you might have trouble with. Alrighty.